All right, so trapezoidal approximations under a curve. Again, I'm going to show you a trig function, sine x from 0 to pi with 4 subintervals, both numerically with the table and graphically. Okay. Does anybody remember what sine looks like on that interval? Anybody? Come on, don't make me break that out. Bueller. It's a wave from 0 to pi. What does it look like? Yeah, it does. Just a hump. Parabola. Peaks in the middle. Let's go to 10. If we continued, it would look like that, right? But we're just considering the first part. Bless you. If I have 4 subintervals, one, two, three, 4, right? So split it into 4. And now we can draw our trapezoids. So it's going to give us a pretty close approximation, not exact. Are we going to have an overestimate or underestimate? What? Yeah, so we're going to get an underestimate. All right, so what's the formula for trapezoid area? Okay, I think you both just said the same thing. That's the formula I remember. You can write the height out front, you can write half out front, there are lots of ways. Okay. These trapezoids, some people really have a hard time seeing them as trapezoids. So I'd say do that. Okay, so you have a base 1, base 2, and then your height is actually from here to here. So that's going to be each trapezoid. Okay. So the height is actually the value of the function, or the bases are the value of the function, and the height is just your interval range. So what is the area of number 1? What's base 1? How tall is that? Right there. 0. And then how tall is this? That's the sine at pi over 4, right?
How is
The value of the
0
function.
connected to the trapezoid?
There's no height. It's a triangle, basically. What you have on the first one. See, this is 0 tall, right?
Right.
This one is sine pi over 4 tall.
Right.
This is sine pi over 2. So this is where our unit circle comes in. What's the sine of pi over 4? Okay. No, we know it's not 0 because it's above the x-axis. Root 2 over 2. And what's the height? That's pi over 4, right? All right, so that's the number 1. That's the area. So we get that's that messy number, is that right? Kind of ugly. But that's okay.
How do you get that?
The top is pi root 2, right? The numerator is 2 times 4 is 8, right?
Yeah.
And then the 2 actually, when you do fraction division, you copy that flip. So that 2 in the new denominator comes into multiply as well. This. So copy pi root 2 over 8 dot flip. Right? And if you get used to just saying if that's a whole number, it goes in the denominator at the top. Okay. So. All right. What about the next one? Number 2. Well, we know the height is root 2 over 2, right? We've already done that one. Which is sine pi over 4. The height of this is sine pi over 2. The interval for the height, what is it? How tall is that trapezoid? And by tall, I mean this direction. Yeah. They're all going to be pi over 4. That's one of the easy things about these. So we get, what's the sine of pi over 2? Anybody? Yay. And we get to do some math, arithmetic. Yeah, it's kind of ugly. I'm going to make that a fraction over 2. So that would be 8/16 on the bottom, and yeah, we'll just leave it. So you're getting the idea of how to calculate the area of those trapezoids. Try number 3 yourself, and let me know if you have any troubles.
When they split, it's the same shape, just like
Anybody else? Okay. Anybody have an answer? Why is it the same answer as 2? Sine is symmetric, so 2 and 3 will actually be the same area.
I told you.
If you do the calculations, it looks like this. Okay, that's how you would plug it in and go. And then what's number 4? Yep, same as number 1. So we get pi root 2 over 16. Okay. So fortunately for us, I picked a nice one. Now add all those up. So I just wrote it out for you. Pi root 2, 2 pi root 2s, 3 pi root 2s, 4 pi root 2s. And then we have 2 pi over 16, and that would be 4 pi over 16. So kind of an ugly answer, huh? Pi root 2 over 4 plus pi over 4, but you can do it all without a calculator. If you know the unit circle, there are no decimals. You're going to see this next year just like it is. So, get used to it. Can I move the paper, or are you still writing? I'm going to show you how to do it with the table, and a lot of you are going to find it easier because it gives you the numbers. And sometimes you're just given the numbers, you just do the math. A lot of times, actually. So, okay. So x is 0, sine is 0, pi over 4, root 2 over 2. Okay, so now you're just given the numbers, right? If you need to draw it, you go ahead. But see how there are 4 subintervals? These give you your trapezoid information. So
this one here, 0 is the height, root 2 over 2, or the base 1, root 2 over 2 is base 2, the height is pi over 4 over 2. And you can generate your trapezoid very easily just with the numerical table. Can somebody tell me what the second interval would look like? Say what? Yeah, root 2 over 2 plus 1, those are our bases. And what's the height? You kind of get the hang of it? This one here. And then the last one. Running out of room here and marker. All right. And you add them up. Again, same answer. I chose kind of a difficult one with the arithmetic. Okay, some of them you're not going to encounter fractions or anything. So I kind of showed you it's about as hard as it gets. Okay, last thing. So you've seen it written like this, right? If I'm going to formalize this, I'm going to write it like this. You see the function, right? And you see the interval. This is called an integral. This is how we write it in calculus. Okay, so we have the integral from 0 to pi. Those are our integral limits. Sin x is the function. And you don't need to worry about why the dx is there, but that's how we write it. You would also be given this information. So this is what would look like another way to write that question. Calculate that. Okay. What if I wrote this? So I add this in front. What am I calculating? Anybody guess? No. We're in integrals now. Derivatives have kind of gone by the wayside. Good guess, though. I don't expect you to know. Just see if I really know. Okay. This is the that's the average height of the function, or average y value. Okay. So if I go to my graph, calculating this right here, so I stick 1 over pi minus 0 in front, it's going to give me the average y value of that function. Okay, just kind of an introduction to what we call the average value theorem. So it's just the average height of the function across the interval. You will see that once and they'll ask you, what does this mean? You'll say this is the average rate of change or whatever the context of the problem is. So just an introduction there. Are we good? Okay. I had your work, and then I'll tell you which ones to do because we don't need to do them all. Let's see. 3, 4, 5, 7, and the free response. The new numbered problems are multiple choice. They'll give you a chance to see if you made mistakes. There's a left Riemann sum. That means use rectangles. Right Riemann sum, midpoint, and trapezoid means there's one of each. And then the free response asks for a trapezoid. Left sum as well. Okay. So just getting some practice there.
Wait, so it's the Riemann sum, is that
That means
rectangle?
yes. So number 3, you would use left endpoint rectangles. Right.
Did you do it?
Monday.
Monday?
Maybe
I did not done it on Monday.
You do. Get as much done as you can in the next 10. I would start with number 5 if I were you. That's the trapezoidal problem. That's the one you have in that practice. Start with number 5. So if you did not hear, 3 on the worksheet I gave you, 2, 5, 7, and the free response. Toodles.